All right, homework answers for section 10.1. Here are the first 17, or I guess, yeah, kind of weird order, but I think you can follow them. I'll pull this down just a little bit so you can see number 14. Pause it if you need to. Rewind it if you need to. You are in complete control. 18, 19, and 20, 21 through 29. Once again, pause it, look over your answers, see how you did. And now we'll go over the problems. I'm not going to go over very many of them in great detail. There's really only one that was requested, both at the tutoring, extra help session yesterday and via request this evening. So 29 is going to be the only one I'll go over in great detail, but I'll flip through the rest of them. I will warn you about problems 3 through 10. I'm sure most of you guys did pretty well on identifying those based on definitions. The big mistake that I do see fairly often is when you're not doing matching, you're doing naming. So it'll give you a picture of something and it'll say, name an example of a chord or name an example of a tangent. And so you'll have to write these things down. And it goes back to the same thing that really plagued a lot of people all the way back in chapter 1, not paying attention to detail. If it's a line, it's got to have line notation. You can't try to say that a second is a segment, because it's not. A second is a line. Those kinds of things. You've got to use capital letters. Points are always named in geometry with capital letters. 11 through 17, nobody really asked about any of those. 18, 19, 20, I'll just remind you that, when you're testing to see if you have a right triangle, if you notice it's a primitive, heck, just say, 3, 4, 5, primitive, that'd be great. Or even if it's like a multiple of a primitive, that would work for you also. But if you don't recognize it as a primitive, or if it's not, you have to test it. This symbol is one we used a lot earlier this semester when we were testing to see if we had right triangles, which is basically exactly what you're testing here. And it's where we don't know if we have equality or not yet. So we'll check it out. We'll say maybe, are these equal? And then, at the end, you can say, no, they're not. So AB is not a tangent segment, or yes, A squared plus B squared was equal to C squared. AB is perpendicular to radius CB. Yes, AB is a tangent segment. So keep that in mind. 21 through 26. Particularly 21 through 23 required a little bit of algebra, but if you actually watched the video lecture yesterday, you would remember, like Homer does here, or at least Homer's trying to remember, example 5, where we used the Pythagorean Theorem. We had to recognize the hypotenuse as 50 plus r, or r plus 50, right? And then we really had to remember that when you square a binomial, you can't just square the two terms, right? You can't make that happen. It's not going to happen. You have to FOIL it out, FOIL it out, FOIL it out, okay? And if you remember that, these problems were probably pretty happy, like on problem 21. Look, he remembered to square that binomial. Yes, remember that middle term. Good job, dude. 16r and 16r is a total of 32r, right? But look on number 22. Oh, they just squared the r and squared the 6. They missed that middle term. Oh, squared the binomial, forgot the middle term. Don't be that dude, right? Um, Make sure you do the 6r plus 6r to get that 12r. Then you'll get the right answer. These are pretty easy if you just remember the algebra. 23. Did we remember the middle term? No. You know, if you could remember the middle term when squaring the binomial, that'd be great. Yeah. And that's the missing piece there if you missed that one. So these were all basically the same problem with different numbers. You've got to do the algebra correctly or you're never going to get them right. These were using theorem 10(2) instead of 10(1). We're just setting the tangents, segments equal to each other. Pretty straightforward. Now on 25 and 26, you actually had a squared in there. Now this wasn't a difficult quadratic to solve because there was no dx term, so you could just solve for x squared and take the square root. There was a little bit of interesting stuff going on. Like on 25, when you take the square root of 4, remember you always have a plus and minus. We studied this, or we reviewed it, back in the fall when we were doing proportions. And sometimes when we were solving proportions, we would cross multiply and get an x squared, and you always get a plus or a minus. Now, usually the minus isn't going to help you because you can't have negative distances. But if I plug -2 into this equation, it's going to square to a positive 4 immediately. And so it does work. You're going to get a 13 whether you put a positive or a -2 into this equation. You have to keep both answers on this one. If you don't, you only get half credit because you missed a full answer. Now, on the other hand, on this one, that -1's not going to help you. It's going to create like a -5 for distance AB. You can't have negative distances. So when you have those squared, you got to be careful. You'll be seeing a lot more quadratics in this section than you have all year. So it'll be a good algebra review for you as far as how to solve quadratic equations. 27, 28, 29 was the big one, right? 29. And I will admit, 29 was a little, you had to look at it the right way. It was a little bit tricky, but once you looked at it the right way, it really wasn't that bad. So let's take a closer look at it here. First of all, what do they want us to find? Well, RS is a common tangent segment. And they want us to find the length of RS given just the 2 radii of the circles, right? QR is 5 and PS is 3. So here's what I would do. I would immediately tack on segment QP. What this does for the time being is it creates a quadrilateral that happens to be a trapezoid. This is a trapezoid. And the reason I know it's a trapezoid is because those 2 radii have to be parallel to each other. Now, the reason I know that is because theorem 10(1) says that the radii drawn to the point of tangency create a perpendicular relationship. And because those consecutive interior angles, angle R and angle S, are supplementary, going all the way back to chapter 3, right? The converse, I think, of theorem 3.6 tells us that those 2 segments, RQ and SP, have to be supplementary. Now, we don't actually use the trapezoid to solve this, but once I have the fact that I do have 2 parallel sides, that means I could take this distance between them, RS, and I can slide it. It's not going to change. It's not going to change distance because of the parallel lines, and I can slide it all the way up here until I get not a trapezoid, but a cute little triangle. Right? And it's not just any triangle. It's actually a right triangle, right? Because we still have the right angle right here. And so that means a squared plus b squared has to be equal to c squared. True. I bet you would agree with that. And so I'm gonna see what I know. I know that this little little piece right here is 2 units long, because basically 5 minus 3 is 2. But I also know that every radius in a circle is congruent to every other radius. So if QR is 5, that means of every other radius, including Q to this tangent point, is 5. And, oh, and guess what? P to this tangent point is 3, because every radius in this circle is 3. It's 3. So that makes this entire piece, turn out to be 8. And so now you have a right triangle. Let's bring it back in, where you have the hypotenuse is 8, one of the legs is 2, and now it just becomes a Pythagorean Theorem problem, right? Let's go ahead and do some Pythagorean Theorem action. 2 squared plus x squared equals 8 squared. Gives us a 4 and a 64, which we can subtract the 4, right? So x squared is equal to 60, or x is equal to the square root of 60. Now the square root of 60 breaks into root 14, or I'm sorry, root 4 times root 15. So that's where the 2 root 15 comes from on this problem. So that's how you do 29. It was the most popular request for last night, and I hope that this answered all your questions. If you do have any left, you're certainly welcome to come to the help session tomorrow at 2 and throw them out there. Probably the emphasis tomorrow will be section 10.2, which will be tomorrow's lecture, but hope this helped you out most of the way. We'll be talking to you soon on lecture 10.2.